Hello, I am Brian Sam-Bodden. Hey, Freddie. And today I'm going to talk to you about jumpstarting your data science learning with Java. And I'll give you a little story. My name is Brian Sam-Bodden. If you are my friend or my enemy, you can call me BSB if you don't want to say all that stuff. So I work for Redis. You can reach me email, Blue Sky, or GitHub. I am one of the Java champions, which I am very proud of being one. And I'll tell you my story about data science. So in around 2012, image recognition was basically picking up again. And I'm like, I got to learn this stuff really well. I did neural networks back in the 90s, where they were toys. They were completely useless. And in around 2012, I started getting heavy into machine learning, convolutional neural networks. And it's a wonderful world. But I wanted code. Just give me the code, and I'll learn from the code. And my programming language of choice was Java. But I joined a master's program, and everything was Python. And the thing that drove me nuts is that I could see experiments working, but the path to production was a chasm. I mean, you have to jump through hoops. And in most cases, they have to rewrite everything in Java and just keep the inference to basically be using really not Python, because it's all C++ and C at the bottom. So the bindings, basically. So today we're going to talk about how you can, in your company, especially with the younger generation of programmers, how we can introduce them to data science, to machine learning, in the language that we can actually take to production. So today's agenda, we're going to talk about the data science landscape, in case you're kind of new to the field. Talk about Jupyter Notebooks. We're going to talk about how to build your own Java data science stack. Then we'll do like one of the traditional data set linear regression analysis of a famous data set from the 30s. And then we'll talk about deep learning with DJL. This is not deep learning 4J. This is DJL, which is a different framework, currently maintained, but also a gigantic download. So things are getting better in the Java world. And then we're going to talk about doing RAG on a Jupyter Notebook with Spring and Redis. I have to throw Redis in there because hey, we're a vector database, and we do it really well. OK, so the data science landscape. So data science, it's a term that basically just started getting morphed over the last 20 years. And right now, it blends everything. It used to be statisticians were the data scientists. That's it. It was just a synonym for them. And then they realized that, well, we need to make this thing work. Then we need to make it work in parallel. And then it's like, well, you're not going to need a computer scientist or a programmer to help you with that. And that feedback loop basically created this new field of data science. I used to hate statistics because it felt kind of like non-deterministic. When you don't understand it. And when I joined my master's program to learn data science, it's like at the beginning it was all statistics. So embrace statistics, learn how to understand data, and every developer in your company will be better for it. So also, we throw the term machine learning and deep learning. So machine learning, it's creating a model that can be trained to do something, some kind of prediction, classification, detection, you name it. And then deep learning basically is what happened in around 2012, where we basically said, hey, we have the computing power now to do this at a much more massive scale. And the architectures got better, like convolutional neural networks, where I guess one of the AlexNet in 2012 was one of those first moments of, whoa, we can really do some cool stuff with this. So we have, the foundations, data analytics, statistics. In computation, this type of field started getting the name data science in academia, mostly. Academia likes to pick really cool top titles for things. Then we had another thing that catapulted this was big data. So now when, with the rise of the web, click streams, the amount of data that came down the pipe actually gave us enough to actually do real experiments against real use cases. Obviously, analytics has been around for a long time. Something happened, we got some data. Tell me how we can make the next quarter in company X better. Machine learning then started basically being used instead of traditional statistical methods or to basically predict things. Customer churn, things of that sort. That also accelerated the field. And then obviously deep learning in this part of the story you guys know. First it was the computer vision. So CNNs kind of did something amazing for the field of AI. And then large language models and NLP, natural language processing, basically kicked off this whole revolution now where we all feel that we might lose our jobs or just might be much fun. I don't know yet. So then obviously we have Gen AI. Every one of our customers is doing something with Gen AI. And one of the things that I find annoying is they're like, hey, we built this gigantic notebook in Python. How can we take this to production? And we're like, well, that's going to be interesting. So now it's basically the world of applied AI, and that's what's in my title. I'm supposed to basically help our customers take large language models and build RAG applications, agentic applications, also work on the libraries that basically integrate with all those ecosystems like LangChain, LangGraph. So I have to do a lot of Python for work too. But when I switch to do Java, joy comes back into my life. So again, quick recap, data science and artificial intelligence kind of touch that set of techniques which are machine learning and deep learning. There's hundreds of these, of basically roadmaps to learn data science. So it's a very broad field. There's a lot going on. If you just specialize in NLP, you can spend the rest of your life there. If you just specialize in computer vision, same thing. So there's so many. There's symbolic AI. There's a lot of places to actually have fun in this field. But you have to pick your path correctly. There's foundational things that you need to learn, and then you can specialize. So let's talk about Jupyter Notebooks. And the thing that at the beginning, I felt that they're making me work like in JavaDoc. I'm in a JavaDoc document that just has a little window where I can put code. This feels silly. I wanted basically a full-blown program that I could run beginning to end, and yeah, that was my world. Fast forward a couple years, and I loved Jupyter Notebooks. There are kind of a better documentation. They can replace integration tests because they are an integration test. So in our company, we actually run tests against the notebooks. So that way, you can basically have an actual practitioner's view of your project that can be tested repeatable in CI/CD. So they were started as the IPython kernel, and basically just having a REPL, something that you can basically type code quickly and get a response. We have had that in Java too for a while, but now we have JShell, which is pretty cool. And it was a browser-based interface because it's the browser. It's where the action happens, and it's a very malleable medium to basically create a nice UI. So it's a browser-based notebook interface. The idea was to basically have, like the notebooks like Galileo used to do for all his experiments and thought experiments with figures, illustrations, data, ideas. And that's the first thing that you do with Jupyter Notebooks. You basically discover, you experiment, you bring in data from different places, you curate the data, you clean the data. So in Jupyter Notebook, you have support for code. So you have blocks that can have, nowadays, Markdown. I believe some of them support ASCII-Doc, too. You have mathematical expressions. You have LaTeX. You have a lot of different things that you can create beautiful documents with it, too. So Jupyter, it's called Jupyter because of the languages that it supports. Julia, initially, supported Julia, Python, and R, the language of pirates. So like you can see here, basically this is what a Jupyter Notebook looks like. You have cells. Those cells, when they execute, they have an output. For example, a markdown cell, executing the markdown means rendering the markdown. So that renders in place. While the code can basically render even graphics, images. You can embed a PDF. It depends on kind of what widgets you have installed and available to your kernel. So you have code cells and markdown cells. Very easy. I and my company have been promoting to basically get rid of some of the documentation in favor of notebooks. You can put a button on your notebooks that says, run this in Google Colab. So you just click on that, go to Colab, and run it on somebody else's hardware so you don't have to pay for it. So this might be hard to watch sometimes, but I'll play it anyways. This is how we were in around 2000-ish. We basically became the #1 language. And you can see where Python is down there. And Jupyter Notebooks were introduced in around 2010. I think the IPython kernel was 2010, 2011. Oh, 2011. And you can see where Python is moving. So my thesis here is that Jupyter Notebooks actually are what catapulted Python into first place. And this is, of course, this is a term of popularity. Popular languages. That doesn't mean installed base, deployed in production. So you keep that in mind when they say, Python is the #1 language. It's not. Who's paying the bills? The Java installations. So how do you build your data science stack with Java? And we are in the era of containers. So containerizing everything, it's the easiest way to give somebody a reproducible environment that they can actually just run in pretty much whatever hardware they also have. Given data science can be picky with GPUs and specific CPU architectures, but most of the low-level frameworks deal with that. And I'm assuming that that's what we're going to do in Java, because basically Java, we are the original right ones run everywhere. So if somebody's going to get it right, it's going to be us. OK, so we are still the dominant force in the enterprise. In here, of course, we're shown as #2. Yay, #2. But again, this is popularity. So these are very, I would say, open source metrics of what's going on. The ecosystem for Java, it's very rich. And I was talking to somebody that, I just added the logo. I was telling somebody that in the early 2000s, when I started basically playing with all this AI stuff again, all of the projects that did anything interesting were Java-based. All of the stuff coming out of academia was Java-based. So I'm telling you, I think the Python notebooks, it's what basically was an inflection point where people started experimenting more in that environment. So it's not the language, it's the APIs in the environment. So we needed this to be in Java a long time ago. So there's a lot of really cool libraries. Today I'm going to show you stuff with the Deep Java library, which is DJL. There's DL4J, which is no longer maintained. Weka is one of the, from New Zealand. This project's been around since I think the late 90s. And it's been an amazing project to work with. There's OpenNLP. I believe it's from Stanford. They have amazing natural language processing libraries. I just found a new project called Smile, too, which basically has a lot of really cool stuff to do machine learning with. And then, of course, you have the standout players like Mahout, Spark, Flink, which are basically, those are production-ready environments that support data science. So once we bridge that gap between the things that are happening right now, large language models in that world, we're going to be winning this battle. Today, I'm also going to talk to you about dflib. How many of you do Python from time to time? OK, so you guys are probably familiar with pandas. So I think there's another talk about data frames in here. But pandas, oh, right, yes. So basically, pandas is a way to basically have tables. in a programming environment that you can do matrix operations against them, transformations, use them to display data. In the Python world, pandas, a pandas data frame typically it can be taken by pretty much any other API and display that data in whichever way that visualization API chooses. So we're going to use dflib today to basically see what a data frame is like too in Java. And of course, we're also going to be, there's the Gen AI at the bottom. So we have LangChain4j, a really cool project, semantic kernel, and Spring AI. And so today I'm going to show you a little bit of Spring AI, which on a notebook. And my goal was that Spring, it's typically people think, oh, there's beans and wiring in XML. It's going to be complex. How can you put that in a notebook? Well, it's actually pretty easy. And it's a very nice place to actually prototype things rather than building a full-blown application. Given building a Spring application nowadays with start.spring.io, it's really easy. But this is actually, I think, easier. And we're also going to play with Commons Math. So how do you build your Java stack? Too long, didn't read. There's a Jupyter Lab Docker stack images. The dflib project actually has one kernel that they support. So there was an original kernel for Java that is no longer supported. So they forked it and improved it and maintained it. So there's multiple Jupyter kernels for Java, but this is the one that I've chosen for today. And I think it's one of the ones that stability-wise is one of the best ones. And that's called the JJava Jupyter kernel. So we're going to install a Docker image of Jupyter Lab. Oh, and by the way, so there's Jupyter Notebooks and Jupyter Lab, and you're like, what is the difference? Jupyter Notebook is a single notebook. Jupyter Lab became more of like a file manager interface that actually can show you Jupyter Notebooks. So not that big of a difference. They just haven't been really good at explaining that to people. Then we're going to pick a curated set of libraries, and I'm going to show you that it's not the language, it's the APIs. By creating a little bit of glue code in the right places to actually glue things together and make the notebooks be legible and easy to understand. So this is a little, you can ignore this. This is a diagram of my Docker file, which I basically told Claude AI to, hey, here is my project. Generate a diagram for the Docker file in Mermaid format, and then I pasted that into a graphing tool and created this. But again, the idea is that you have a Jupyter container. I also have a Redis container running in this Docker Compose application. I have my Jupyter Lab installation, and then I have my Java kernel installed, and of course, the Python kernel comes in by default. So in this installation, I'm going to be able to use either one. But you can only use one language in one notebook. You can't mix and match. And then I also have Maven dependencies, because who wants to try to drop a jar in a folder like it's 1995? So you can use Maven, declare your Maven dependencies at the Docker container level in a POM file. And I'm using my Docker file to read that in and make those available to all my notebooks. There's also what they call Maven Magic to basically load Maven dependencies. And then, so we're going to have Jupyter in our Redis database available to us. You can ignore this too, but this is the Docker image. Has the Jupyter Docker image as a base. I installed Java 21, because if you're not using at least Java 21, you are living in the past. We got to move forward. The JJava kernel, and then the utility glue code, I basically also load into my Maven space. All right, so let's talk about the JJava Jupyter kernel. So again, one of the many OSS Java kernels. It is really well maintained. Executes via JShell, which is basically how everything interactive in Java works nowadays. And it requires Java 11 or newer. All right, so let's explore. Yes?
Is it related somehow to JShell? Is JShell behind it, or how it works?
Yes, yeah. It's what they use in the core of the actual execution of the REPL. So yeah. All right, so I'm going to switch. So just to show you that I'm not lying here, there's my Docker environment. And this one, I call it Redis AI Java Resources, but you can see that it has a Redis instance and the Jupyter instance in there. And then on the project, I have my Docker Docker Compose application running, and you can see the structure of my project. You can see I have my Java glue code. It's a Maven project that lives inside this project. And then I have my Jupyter installation with the Java kernel installed. And I have a set of notebooks. So pretty simple. I'm going to give you the link to the project so you can basically clone it, take my stuff out, put your stuff in, and you're good to go. All right, so this is what the Jupyter Lab interface looks like. You can see that there's a file browser on the left, and then you have a starter page that allows you to create new Python notebooks. And if you have another kernel installed, you can create a Java notebook in this case, because we have the JJava kernel installed. So the first thing I'm going to show you is a very simple notebook. And let me make it a little bigger. OK. So one thing that I like to do is view and hide the file browser so I can have a little more real estate. And you can see here, this is a markdown cell. So if I double click, I put it in edit mode, you can see that it has a H1 title, some text, and an image in there. And if I get in there and I do like a control enter, it renders the markdown cell. So that's one of the types of cells. But there's people that provide widgets that gives you new cell types, so you can basically find all kinds of PDF viewers, different things that you can actually put in a notebook. So the first thing I'm going to do is, hey, hello world. So notice that on the left there's brackets. So when it's executing in the basic flavor of Jupyter Notebooks, you're going to see an asterisk. And then you're going to see a number that shows you basically the execution order of that cell. So let's go ahead and run that. And you can see hello world shows right below it. And now that's cell number 1, because we executed that. And now let's do something a little more complex. So I have this big chunk of code in here that, notice at the end, I basically have a display data and a display image. All so I can do this, OK? So let me execute those cells first to make sure that the interpreter, the JVM has that code available. So I'll run that one. So that becomes code cell number 2. Let's run this one too. And now I can run this. So that was a lot of code just to display an image from the file system with Java. But the cool thing about this is that that code doesn't have to live in the notebook. So typically how I work with Java in notebooks, it's I do it all in the notebook first, and then I go like, oh, OK, so that's a utility for sure. This should be part of that project. Why don't they have this? So you can also contribute things back to the project under the guise that it's like, hey, this is going to make it easier to use in a notebook environment. And of course, all of your Java, it's available to you. OK, so now I did what I said. I basically took that code and put it in my glue code library. And now I can just import that Java glue core J, which I basically keep collecting utilities in there. And again, it's up to you if this is going to be something that you keep internal to your company or that you contribute back to one of the projects that you're basically creating glue for. It's really up to you, but the main goal is to make your users understand what's going on in the code. And in your company, you might have domain-specific things where basically having those static methods with the right names is going to make a big difference. So now I can run this, and I can run this. Notice that, they talked about this in the keynote, that, system.out println, it's annoying. So I, put one static that basically pipes to print to system.out println. So I can just do println hello world. New Java is going to fix that, but hey, yes?
Can you explain a little bit more about the glue project? Is that something?
Oh, that's just me. That's just me. So we have internally a similar thing at Redis. So basically, I can make the Java code basically be as good or better than the Python code.
Yeah. Right now, I'm living in the AWS world.
Yeah.
AWS Glue, and
Yeah.
I have the name.
Oh yeah, no. I just couldn't find a better name than glue. Yes.
So how does JJava know how to read your glue code?
Yes, so I just imported the glue code, but what I did in my Docker file, I basically load those, I compiled the project, the Maven project, I build it, and I load it as part of the kernel too. So that's all in the Docker file, so if you get it, yeah.
How do you know the project is part of the kernel?
So there's nothing to view dependencies available. So imagine it's like somebody basically, you don't have access to the POM, but you can actually explicitly create a POM inside of your notebook, and I'll show that in a second. All right, let me quickly move here. How are we doing? Oh, we're doing good. So that was the JJava kernel, and again, it's Java 2 verbose. I don't think so. And it's getting better and better and better. So it's lack of smart defaults in a lot of APIs. And the best thing to do for a notebook is to have static methods. Those static methods that do basically the 80% use case that everybody does. If you see somebody writing the same 8 lines of code, functional decomposition, if it's your library, you're gonna be like, well, that should be a method because we're always doing this same thing. Maybe with some parameters, some smart defaults, but then you clean up your code. And we do that all the time with our Java code. When we see an API that bothers us, we just make it better. So the glue code, again, very simple. Like this is the example from that print line. I just have a class called J because I am really bad at naming things, as most programmers are. And I have a print line that just basically pipes to the environment print line. So pretty simple. So now let's actually do linear regression with the iris dataset. And this is a dataset that basically of flowers. And the idea is to predict like the petal length, the sepal length and height. So it's a very simple data science data set. And it has about 150 data points, so it's a very small set. This was collected by hand in 1936. So, but it's one of this MNIST and the Titanic data sets are like the ones that get used over and over and over for data science intros. So that's the one why I picked this one. So actually, let's look at the notebook and see how we would do this. So here's the Python version of it. Python dependency management, it's a hell you don't want to be in. It makes Maven feel like a holiday. So, there's going to be recorded, and I'm going to be in a Python conference, and they're going to chase after me with pitchforks. But so the idea of one of these notebooks is that you basically do some downloading of the data, preparation of the data. Sometimes you basically clean the data in ways that's going to make it easier to manipulate. And in here, we have basically a pandas data frame where we load the data into that data frame, and then we can print that data. You can see the sepal length, width, length, petal length, and petal width. And you can see down here, we are basically doing some very simple data manipulation. And down below, typically, this is what happens in data science notebooks. You basically do a lot of exploration and analysis of the data. These are the different types. This is how many of these categories exist. You do a lot of a few bar graphs, a few pie charts for everybody to get a cursory understanding of the data. And then you get deeper and deeper into it. So here is the typical pair plot. So this is from Seaborn and Matplotlib working together. This is a plot that you see in every notebook with data like this. And in here, we're basically predicting the sepal length. So this is linear regression with Python. And you can see that there's an LR class that it's a linear regression class. And down here below, we do a predict. And we basically separate our data into test and training data. And then we basically sometimes keep a little bit of data too to actually do some testing at the end. And then you do some predictions. And you see basically what you get. But this is Python. We don't want to see this. So here is the Java version of this. And you can see at the top, this is what I was talking about Maven dependencies. So you can bring your dependencies just like you do in Gradle, shorthand notation for Maven coordinates. So this is called the Maven magic. Everything that it's not a programming language command in Jupyter Notebooks, it's called something magic. you can see here that I ran these two because sometimes I'm loading Maven dependencies. Have you ever tried to do an NVN compile in a plane? Well, yes. So that's I'm not relying on conference Wi-Fi, so I did this earlier. So I ran those first two cells, but now I have a CSV file in my system. So I'm going to basically run this block of code to basically load my CSV file. So you can see here that I have a ds.show preview. ds, it's one of my glue code classes. Because this was like 3 lines. I'm like, nah, I want 1. And that's not always going to be the case. Sometimes you need that code for understanding of what's going on, but sometimes you don't. So in here now, we're going to explore the data set. So I have a few cells to do that. You can see here that I print the columns. I do some sampling to basically show what type of values we have in there. I want to show the shape of the data. So when you have a matrix or a data frame, you typically want to know rows by columns, what am I dealing with? And now in here, you can see that there's 50 samples of each type of flower. So the categories are, I believe, Setosa, versicolor, and Virginica. So now we can start doing visualization. So this is when it starts getting fun. So in here, I called a plot that I created myself in that glue code, which should be happening right. I don't know what's going on. Did I disconnect it? No. Oh, yeah, OK. Sorry, that was just setting up the stage for it. No. God dang it. I broke it. Oh, yeah, my DF is null. Did I? Yeah. Did I not run a cell?
You're just demonstrating the main pain point of Jupyter Notebooks.
Yes, yes.
If you don't run it in a
Yes.
specific order, you get things like
Yeah. Sometimes it's better to say basically run everything from the top to the bottom. But let's see. Oh, yeah. My data frame got blanked somehow. OK.
It's not, I use the app instead of only the app.
Say that again?
Yeah, it says df is null, but you're using I use the app.
Did I try to rename things? No, there it is. So this is one of the plots. So I use a JFree chart, which is a very common Java charting library that's been around forever. And this is one of the easy to do plots in there. And here's a few more. A histogram. And this is the one that I did that took actually a little bit of code. So I saw that Seaborn had this pair plot, and I wanted to recreate it in Java. So basically, I did that with JFree chart because it's a library that I trust. It's written in Java. It's really performant. And there is the equivalent to the Python world, which you saw on this slide right here. Yeah. So very similar. Then you can do things like I can do some data manipulation, so I can basically do my linear regression. So I built a linear regression model. So that linear regression class I created using Commons Math. Commons Math has all the utilities to do linear regression. So for this, I didn't want to bring a gigantic AI library to do this. So Commons Math, it's tiny, it's very efficient, and has been around forever. So I have a pretty good amount of trust on that library. And after I do that, I can create my predictions. So you can see here predicted versus actual. And then all the typical, R-square, RMS, all the data scientists love to hear all this, F1 scores. Their mouths salivate when you say those. And finally, here is the line of the actual versus the predicted. So linear regression 101. All right, so now let's look at, I'm going to skip some of the slides and look at a different project. So in this one, I'm using DJL, and I'm going to do some object detection. Okay? So I have my Maven imports. And then I ran all this, so basically to save time. But you can see there's an image of a very cute dog, a bicycle, and a car. And now with DJL, you have this model discovery where you can say, these are the criteria of the type of model that I'm looking for. I want one for object detection that maybe works in this platform that returns this type of object. So in this one, you can see that I said I need a CV object detection model. So I ran that, and it downloaded the model locally. So once you do this once, then you have the model weights installed locally for this. Same thing applies to like LLMs and things like that. So now I can basically run some detections, and notice that it's dog, bicycle, truck. There's probabilities for each detected object. So now let's actually visualize that. So I'm going to draw bounding boxes around the different elements that were found. So you can see the dog was detected, the bicycle, and the truck. Very simple. You can do CV in Java, a few lines of code. All right. Another thing that I did, it's we at Redis, we work with vectors a lot. So sometimes it's nice to visualize a vector. I'm not going to run this one, but I saw this in a Python article where they basically visualize a word embedding by using this kind of like rainbow DNA chromosome strip thing. And I recreated that with AWT in Swing. So this one was a little bit of brutality there, but hey. But that way you can visualize embeddings, and the colors should kind of match when two vectors are in the same spot in that hyperdimensional space of the embeddings. Now, another thing that I wanted to show you, let me see, how are we doing? Oh, yeah, 4 minutes. Oof, we got plenty of time. I'll do some slides here. I wanted to show you this picture, obviously. So, yeah, we saw the Python version. Don't get strangled by the snake. We did the Java version. So JFreeChart is what I used for the charting on that first example. dflib and Commons Math for the linear regression. We've seen some of the DJL stuff, very easy to use. But DJL is one of those frameworks that depends on a lot of the C and C++ bindings to the same way that Python does. So when you download one of these, they're massive. There's a lot of stuff in there. So the last thing I want to talk to you about, it's RAG with Spring AI and Redis. So why Spring? Because it's 60% of apps out there in the enterprise, traditional businesses, insurance, banking, fintech. Spring, it's actually very dominant in there. So it makes sense for people to be able to experiment with Spring in a notebook environment. Redis, this is my only pitch. We are, if you ever needed to add caching to a slow application, you know us, but we're also a vector database. So we have a native vector type in our hashes in JSON, and we are the fastest vector database out there. So this demo, basically, I took an application that a coworker of mine wrote that basically allows you to chat with a database, a beer catalog, and ask questions about the different beers in there. So you have a transformers embedding client in Spring that basically can take some of the data from this data set and create embeddings. Those get stored in Redis, in the vector stored Redis. So there's a JSON document for each one of the beer types. In one of the fields of that JSON document, it's the embedding. Then we have a chat client, which it's the typical OpenAI chat client that is going to talk to this service. And in the service in the notebook is just a cell, just a function that I put in there. And what it does is just the R of RAG, retrieval. So somebody asks a question, I basically vectorize the question, I go find relevant data in the database, I add that to the prompt, so I enhance the augmented part of RAG, and then I send that prompt to the LLM to get an answer back. All right, so let me show you that before we get out of here. This one was a test just to make sure that basically Spring AI worked in here. I did the same thing. I loaded all the milestones in here, all the Maven coordinates that I needed for Spring AI. So you can see that I have the OpenAI transformers and Redis store. I also need simple log4j, obviously, in Redis, which is a Java client. So I'm going to go ahead and run this. Boom. So I have built my chat model there using my OpenAI key. also in the notebook, I added a .env file, so you can basically put your secrets there, and they get loaded in the notebook. So you don't, in some Python notebooks, sometimes you prompt the user to put their key to basically do that. I don't like that, so I like to have an env file that's squirreled away in the back end, and nobody can see it. So I'm going to set the embedding model. So this is what's going to take the input and create vectors that I can store in Redis. And I'm going to test that embedding model. So I'm just going to say, hey, embed in bulk these two sentences, hello world and world is big. And then I'm going to check the size of the embedding, the collection of embeddings. So I have two embeddings generated. And each embedding's dimension, well, I didn't print the dimensions, but yeah, I think these are like the, 764 maybe. So that's what an embedding looks like. A bunch of floats in an array of floats. I want to bring the term float parade into the vernacular. So now in here, I basically connected to Redis, created a Redis vector store that's part of the Spring project. You can see that it's going to have an index, so I can basically do search over this collection of beers. And each key in Redis is going to have the prefix beer. So I can quickly show you what that looks like in here. I believe this database is the one. So you can see here, there's beer, because that's the prefix of those JSON keys that I preloaded in there. So this is quite a bunch of them. And you can see that there's an embedding, and there's content. So that content, it was used to create the embedding. So I have the data and the mapping to our vector space. So now, since I already loaded the data, I have a big if in there that says, check the database. If it's there, don't do this, because it's in a GZ file. So I have to unzip it and then load all that data, which is a significant amount of data. But you can see here that embeddings already loaded, skipping. The demo gods have been with me. So I have a system prompt for my little RAG simple application, where it says you're assisting with questions about products in a beer catalog. So you kind of basically guide the LLM to try to do the right thing. So this is like the first step in basically creating a RAG system that doesn't do horrible things. And then I'm going to create my chat client. And then this is the function that basically wrapped the whole RAG implementation in a single place. So I get a query. I call the question the method ask. I'm using global values that basically were created before. So you don't have to go completely crazy with encapsulation in a notebook. It's OK to basically violate some of the rules of object-oriented development when it comes to experimentation. So I have a search request to Redis that basically passes the query, and I say I want the top 10 K or hits. So when I find the neighborhood of my input, it's going to go around and find the closest 10 vectors to the one mapped by the input query. Then I'm going to retrieve, using similarity search, those documents from Redis. I'll do a little bit of mapping to basically make them legible in the prompt. Then I'm going to add those documents to the system message. And then I'm going to create my user message. And finally, I assemble the prompt at the end with the system message and the user message. And then I get my response. So let's run that. And like what you were saying, it's true. If you're demonstrating a notebook and you're doing it like piece by piece, like I'm doing this, and you miss a cell in the middle, you might be completely baffled about why that happened. So now we can actually interrogate our RAG application. So let's first ask, what beer pairs well with smoked meats? And basically says the oat smoker. So this is only from the catalog of beers that we have in our database. So again, that's how you basically do the retrieval and encapsulate the responses of the RAG system, not to basically step out of bounds. And this is the question that I have asked since I was 25. What beer would make me lose weight? I find out if you drink enough beer, you'll feel so sick for 3 days that you will lose weight. So any beer would do. So that's how you basically get a RAG application using Spring, which is typically considered a dependency injection framework. How am I going to do this in a notebook environment? So if you can do it with Spring, you can do it with pretty much anything out there. So back to the slides. In closing, Java, it's ready to become the dominant data science, machine learning language out there. Project Panama, all the things that we're doing, it's going to make the nightmares that you have in Python right now go away. Because again, the promise of write once, run everywhere, or anywhere, it's going to be realized for this AI world. Again, to learn data science for new employees, all employees, employees in the middle, if you don't want to learn a new language, which it's okay to learn a new language, obviously, but you have expertise in Java, you can actually get into data science with Java nowadays. I'm a big advocate that this is executable documentation and it's better than JavaDoc. So I hope that we do something in the Java world where JavaDoc and something like a notebook environment come together. And it is a de facto communication medium in the AI, ML, data science community. If somebody asks me, hey, how do I do that in that world? Typically, you send them a notebook. You don't send them a chunk of code. You send them a notebook, and they know how to basically run it in Google Colab or in their own installation. It has become the de facto communication medium for data science, machine learning, AI, et cetera. You can get this project at that GitHub repo. And feel free to clone it, drop all my glue code, add yours, add the libraries that you like. It's very easy to get started this way. And it's in Docker. So I know the architecture that it was created for. So it's going to work on your machine if Docker can work on your machine. And thank you.